This is the second lecture I'm taking in the post-mid semester, and this is the very first video lecture I'm doing right now. So I'm also a little bit nervous in doing direct uh, video lecturing. So please apologize me if there is any mistake in the lecture. Okay, I would like to rectify those mistakes during the discussion sessions. Okay. The first is that I would like to go back and see what we have done in the previous lecture. That's on 2nd March 2020. Okay, I have introduced two set of examples. The first example is that it's pasteurization of France and the second example COVID-19 to understand the laboratory and society interface. Laboratory society interface. Okay, what is the relevance, what is the importance of trying to understand the societal aspects of science, as well as how do we incorporate those aspects into the laboratory understanding of our scientific investigations on experiments and observations and so forth. Okay, so I gave this example of this pasteurization of France and as well as the COVID-19 to understand the nature and the character of microorganisms that cause a particular disease. So, the laboratory specifically attempts to understand the nature and the character of the microorganism that produces a particular disease. Why we are supposed to understand the societal aspects? Because when you understand the societal aspects of the disease, you will be able to understand, you will be able to put a kind of a question how a microbe behaves in an uncontrolled environment, which means there are certain social conditions responsible for the production of disease production as well as the spread of the disease. Certain social conditions responsible for production and as well as the spread of disease in the society. Okay, so I try to explain you that how to infer, how to get the data for this. And I said multiple institutions, multiple set of actors, one can try to interact with them and try to collect a kind of information. For instance, it's from the hospitals to the industry which produce drug. So why do we need to understand this multiple set of actors? When you understand the multiple set of actors, you will be able to collect informations, different set of informations from each actors, and finally you will be able to categorize those informations in two terms. One is in terms of a numerical sense, and other one is non-numerical terms. Okay, so the informations, whatever the informations which we try to collect it in terms of a numerical as well as non-numerical terms, use these numerical and non-numerical informations to understand the disease, at the same time vice versa understanding the microorganism. So we need to know how a microorganism behaves within the laboratory. At the same time, we are trying to understand how the microorganism behaves outside of the laboratory. When you try to know this, you will be better understanding what is the nature and the character of the microorganism is. So the way the laboratory and the society is interlinked, one way is to understand it in terms of an internal aspects of science and then the external aspects of science. This internal and external aspects always go hand in hand, or the internal aspects influence the external aspects, the external aspects influence the internal aspects of doing the science. Okay. Now I would like to kind of relook at this point of view once again before rubbing this. I try to introduce the very idea of two examples, for instance pasteurization of France and the COVID-19, to understand, for instance, how the epidemic transforms into a pandemic situation. This is very local in nature, this is the global in character. So the transformations from the local to the global level. So I introduced this two set of examples to make you to understand the interface between the laboratory and the society. Okay, when the scientist, for instance, the Louis Pasteur's work is on trying to understand the microorganism of anthrax. Anthrax is a kind of a microorganism. To understand this, how this disease spreads through this microorganism, he not only investigated this microorganism within the laboratory but also outside of the laboratory, because most of the people are being affected by this particular microorganism. So here the specific understanding is that how a microbe behaves in an uncontrolled situation. This is what the primary question is. So which means exactly the social condition, there are certain social conditions which are responsible for the production as well as the spread of the diseases. For instance, the social conditions of, for instance, unhygienic conditions. Unhygienic conditions which are highly responsible for the production as well as the spread of the diseases outside of the laboratory. But if you are within the laboratory, the microorganism is highly controllable in nature, because which is highly hygienic, which is highly a kind of in the laboratory which follows a set of procedures. When the laboratory follows a set of procedures, this microorganism behaves in a different ways. So in order to know the nature and character, he moves to the societal level to collect the data. He tried to collect the data in numerical sense, in terms of numbers, as well as non-numerical sense, that is in terms of practices. So now, before getting into the idea of this particular class which tried to attempts to establish the connections between the data and the informations. Okay. So I will be, in this particular class, I will be more focusing on the connections between the data and informations. Okay. But before understanding the connection between the data and the informations, we are supposed to understand what is laboratories. What is the very fundamental idea of the laboratory? What is the role of the laboratories? It has two given rules. The first one is that it deals with the history of ideas. It deals with the history of ideas, which means it exactly attempts to describe, focus on the socio-technical problems of a given time. This is number one. It also records regular events that happens at regular interval of time. So the primary understanding of a laboratory, the first one, it deals with the history of ideas. That history of ideas is specifically focused on the socio-technical problems of a given time. Okay, the second one is it also attempts to always the laboratory focuses on recording regular events that happens at a regular interval period of a time. So for example, if you look at this in terms of an example, I would like to give an example of, for instance, very kind of, and the famous example is Tesla versus Edison, understanding on AC current, alternative current versus DC current. Edison proposed the DC current, that means the direct current. The direct current has a certain problems. You cannot change the value. Number first, changing the value to high, low is impossible. Number two, huge transmission and loss. Huge transmission loss may occur due to the DC current. Number third, you cannot take the electricity to the long distance. So the taking the electricity to the long distance is something which is limited in the form of a DC current. So the Tesla revised this Edison's understanding on the flow of current, and he tried to introduce the new set of ideas, that's alternative current. The alternative current could able to address all these problems. One can change the values from high to low, then you can also reduce for instance the transmission loss, and you can take the current to the longer distance by introducing for instance the transformer, the idea of transformer, along with that the changing the direction of the current, that reverse mode, reverse modality of moving current from right to left and left to right, okay, or in a circular ways. Okay, this is what a kind of a good example of in the history of ideas, where you move from one idea towards another ideas. Though, so the laboratory which will be highly focused on the trajectory of this idea, how an idea travels, or how an idea, the trajectory of an idea moves from one phase or one stage to another stage. This is the crucial important thing for the development of a theory. Development of a theory or given set of principles. Okay, so the laboratory which will be focused on this, the trajectory of ideas. Okay, that means that which could lead to the development of a theory or a given set of principles. Okay, And the second set, the second idea of the laboratory is that it deals with the set of institutions. This set of institution, which means it organizes the field, rationally it organizes the social field of science. Rationally organizes the social field of science. What it means, the rationally organizing the social field of a science means, when you go to the laboratory, you will be able to see all these objects. For instance, it's a physical setting. Number second, you will be able to look at that it is also made of, it consists of materials and chemicals, and it also deals with instruments and machines, knowledge aspects as well as the procedures. You try to look at knowledge in terms of two things. One, implicit knowledge. Second one is explicit. You will be able to see this explicit knowledge in terms of books, journals. The implicit knowledges are your inner assumptions. Inner assumptions about the object of investigation. Okay, so you will be able to rationally organize all these factors or all these variables in the form of experimentation. In the form of experimentations. However, what guides your experimentation is that it's the history of ideas. Always remember that it's the history of ideas guides your experimentation process. Unless you have the strong understanding on the history of ideas, you will not be able to develop any experimentations, any method of an experimentations in your project. So you should always keep it in mind that the very idea of the laboratory, which deals with the history of ideas, that means it's a trajectory of theoretical development, and also it deals with the set of an institutions. That set of an institutions is about rationally organizing the social field of a science, which means it involves a different set of variables. It's a physical setting, it's a kind of a room, material, chemicals, instruments, machines, knowledge in the form of an implicit knowledge. You have a kind of an inner assumptions within your mind. At the same time, you have a kind of an explicit knowledge, the explicit knowledge in the form of a book as well as in the form of a journals. Yeah, and also you follow certain procedures, how to do certain experimentations. All are fundamentally part and parcel of making a kind of an, or arriving at an experimentation, arriving at a kind of an, whatever observations you want to do, whatever kind of an experiments that you want to do, you will be able to look at the logics within this frame only. So what guides the logic of an inferences, what gives that logic of inferences is that it's the history of ideas which gives you. So if you miss the history of ideas, you will also miss the very idea of how to make an experimentation, how to make a kind of a very good experimentations. Okay, number third one is about the laboratory also guides. The laboratory eventually results in the scientific work. So what is the very fundamental aim, the motive or objective of the scientific work is that to come up with a kind of an to come up with or to search for the knowledge. Either it's the search for the knowledge, or you can call it as the production of the truth. Okay, this is a very fundamental objective of the scientific work is that, and eventually, what do you are trying to come up with this? What is the eventual outcome? Is that either the eventual outcome, the production of the truth, it's in the form of, for instance, discovery, or it is in the form of an invention. We will be able to see what is discovery and what is inventions and the further explanations of discovery and invention in further classes. So I'll be like more limiting my explanations. What is discovery? Is that it is the discovery, which means it's the novelty of a fact. Your fact is very novel in nature. There is a newness to the fact. What is invention? The invention is about the novelty of a theory. This is kind of a purely a Kuhnian understanding of what is discovery, what is invention is all about. That when you look at that inventions, it is about you are coming up with a kind of a new theory. That means you are trying to establish new set of assumptions. That assumptions which explains about a phenomenon. That's what the theory is. But in order to come up with a kind of an inventions, you need a certain fact. Now the question is that what is the connection between the fact and the theory? How we are trying to establish the fact and the theory. So you need data here. Here we are entering into the idea or the discussions on what is data. Always remember in mind that the data is a representation of a fact. Number one, it is a representation of a fact, as well as it is also a representation of a concept. So always the fact connects to the concept. So now the question is that, now the idea is that, what is fact? What do we mean by the fact? For example, I would like to give a kind of an example. The fact, for instance, a car traveled at a speed of 80 kilometers, which that covers 400 kilometers. Now I want to know the exact time which the car has taken to travel the 400 kilometers. So I just put it into a kind of an conceptual understanding. What is the time frame? Time is equal to distance divided by speed. So now it will be t equal to d by s. So the distance equal to 400, speed is equal to 80, you will be getting 5 hours. So the car has taken 5 hours to reach 400 kilometers. So this is, the time is a concept, okay, but you are trying to explain this particular concept, you look at that how many factors you needed to explain the concept called time. You need how many kilometers, at what speed the car has traveled, and how long it has traveled. So you need all this information to come up with to explain the concept of the time. Suppose if you look at the concept, what is the definition, what is the very idea of the concept in terms of, and for instance, good example of what is velocity. What is velocity? The velocity is it's more about, for instance, trying to come up with an understanding of it changes the object, changes the positions as well as the direction. Okay, so along with the distance and as well as the speed calculations. This is purely an understanding of velocity. So when you collect the fact, you should always try to look at that whether the fact will be helpful to explain the concept or not. Suppose if my fact is not able to explain the concept, that means I have a kind of a partial fact in my hand. That means either I may have a partial fact, or in other way you can understand it, I don't have a fact at all. So always try to think that what is fact in connection with the concept, whether you are able to explain the concept properly or not. Okay, so this is what the data, what is the real understanding of the term data means. The second is that, okay, I also would like to do a kind of a revision of this. The first one is that I make you to understand that what is the scientific work is. What is the very idea of the scientific work? The laboratory deals with the very idea of the scientific work, and the objective of the scientific work is to search for the knowledge or the production of the truth. So what really matters here is that the production of the truth, which is related to the discovery, the production of the truth is related to the invention. What is discovery? The discovery, which means it's a novelty of a fact. Okay, there is a newness in a fact. The second one is that what is inventions? And invention is about novelty of a theory. How theory emerges, how fact comes into the situations. Okay, the fact and the theory relations. How do we establish the fact theory relations? Before that, you have to understand what is a data. If you want to establish a fact and you need a data for it, what is a data? So the data is about the representation of the fact. Okay, and the representation of the fact, which means it clearly explains an objective reality. It describes, a statement describes the objective reality. For instance, what happens in reality. For instance, now I'm exactly trying to do a kind of a video lecturing. So when I do the video lecturing, what is the concept which is being, I do a kind of, I'm taking a class. So when I take a class, it's purely a kind of a lecture. Okay, I'm doing lecture is a kind of a concept. When I'm trying to explain this through the via medium of a technology, and it's purely a kind of making students to take this particular class. The other way to put it in another way around is that making you to understand how to do this. Okay, I just a kind of an okay, I'm trying to do kind of the lecture is a kind of a concept. So the fact is that I'm making presentations in front of the camera. It is very difficult for me. So that very difficult it's purely an objective reality, because I'm so tensed. Okay, it's so tensed is purely, it's a kind of a fact which is being produced at this moment itself. Okay, that's what you can call it as a kind of a fact. But what is the concept here is that it's a lecture. So what is a lecture is, it's more a kind of an indirect lectures which I'm doing. Indirect method of learning. This is a concept. Indirect method of learning is a concept. What is exactly which is happening in front of you is a fact production which is happening. Okay, that's what the relations between the fact and the concept relations. Okay, so after this, so I made you to explain that a given example of a car travel at a speed of 80 kilometers per hour that covers 400 kilometers. Okay, then what is the time which is taken to cover that particular distance? Is that the time is equal to distance divided by the speed. Okay, the t equal to d divided by the s, 400 divided by 80, which is equal to 5 hours is that time. So you have to look at that, whatever the informations which you collected, okay, it should able to explain the concept or not. Okay, for instance, if you look at that, what is the velocity? If you directly like looking into the much similar concept of the speed, the velocity. The velocity is about, it's also positions, it is also about the directions. That means how an object changes its positions moving from one place to another place, and also it denotes a directions, whether it moves in this directions, right directions, or left directions, north or south, in which angular conditions it moves. So you're also trying to describe the direction of an object, okay, which moves. This is how you have to establish the fact concept relations. The next idea is that how do we derive data? How do we derive, or how scientists derive data? There are two ways through which the scientists derive data. One is it's an experimental methods, through an experiment. The second one is field. Two levels of data we can derive. One is through the experiment and another is through the field view. What is experiment is that we are trying to collect the raw data. Collect raw data in a controlled environment. Field data is that deriving data in an uncontrolled environment. The field is about you're trying to come out of the laboratory and trying to observe what happens in and around you. Okay, so it is specifically but the field data or the experimental data. The field data as well as the experimental data, you try to collect the raw data in a controlled environment. That means, what does that controlled environment means here is that all the variables related to the process of scientific investigations. All the variables related to the process of scientific investigations are highly controlled by the researchers. Here, when you come to the field data, all the variables are uncontrolled. That means the researcher he or she doesn't have any control over the variables. So, always how do we derive the data is that one is through the experimental, and another one is that go to the field outside of, for instance, you're going to the field, you're trying to collect a kind of an, you're trying to observe what happens in the field or what happens in the village and trying to collect certain informations. These all are, which is highly, you don't have any control over the variables, but you are still a kind of an observer. You just start observing it and you try to collect as much as possible informations for your whatever it is required for your experimentations, and you collect those informations and you bring those informations to the laboratory and you are trying to look at that what sort of variables are important for your idea, for your the project. Okay, so you're trying to look at those variables and you formulate those variables and you start investigating. You start investigating within the laboratory. So this is what the connections between how do we derive. One is through the experimentation process, other one is through the field observations. Now the question is that what does that raw data means? What is the idea of the raw data? The raw data is about the data which is yet to be processed. Yet to be processed or analyzed. So the very idea of the raw data is that the informations are yet to be analyzed, or the informations are yet to be processed to get a kind of a solid inferences for your study. Again, that's what the raw data means. Okay. So the next idea is that here I try to make you to understand what is data and how do we derive the data. The data you are able to derive it through the experimentation process, through the process of experimentations, and through the process of the field observations. Okay. So now the second understanding is that what are the different types of data? Different types of data you have. The first one is, it's a primary data. The second is, it's a secondary data. The primary data deals with, it's a first-hand information collected by the researcher or by a researcher. Okay. The second one is, it gives you a basic explanations about an object. It gives you basic explanations about an object. What is secondary data? The data collected by someone else. What? Researcher would like to use for his or her analysis. Okay, that's what we mean by the secondary data. For instance, the secondary data are indirectly inferred. Okay, so you will be able to take this the secondary inferences from books, journals, reports, archives. All these are fundamentally part of the secondary data. The first-hand information is about primarily the researcher goes to the field and attempts to collect the data, or the researchers being within the laboratory, he or she would able to investigate the process and try to do a kind of a small experiment and try to get a kind of an inferences out of those experiments, whatever he or she is trying to do. Okay. Apart from this two level of an understanding of the primary data and the secondary data, there are another set of two levels of an understanding. One is, we call it as an metadata. The metadata is an information about the nature of information. Is an information about the nature of information. Okay, that means, for instance, you go to a kind of a particular place, locations, or certain geographical locations you travel, and you're trying to infer what kind of a geographical locations it is. Okay, you go to a village and you're trying to kind of infer an idea on basic amenities. This is purely an metadata. Nobody explains you. Okay, you are only trying to get a kind of an inferences by being within that particular locations. That's what we call it as a kind of a metadata. Metadata is part of a kind of the primary data. The second one is derivative data. Derivative data. Derivative data is some kind of an indirect source. You're trying to get a kind of an indirect information from a particular source you have. For instance, a good example is that you will be able to tell that a particular person being in a petrol pump on this particular time by looking at the slip of that petrol pump slip or petrol pump bill. Okay, you will be able to tell that, okay, this person was here at this particular point of a time on this date by trying to look at the bill. Okay, if it is written a name on it. Okay, so that's what we call it as a kind of a derivative data. You are able to indirectly infer certain informations from a particular source you have. Always remember that this derivative data as well as the metadata are part of the primary data. Okay. So you should always keep it in mind that don't think that you will be able to get certain informations only by interacting with the people. You can also get informations by being within the environment, by being within the situation itself. Okay, but if you have to look at that, you have to look from the very idea of what is that metadata, what is that derivative data, sir. Okay. The next is that what is the nature of the data, whether the nature of the data is numerical or non-numerical in nature. Numerical data as well as the non-numerical data. Numerical data is about its numbers. It will be in 1, 2, 3 representations, number representations. Non-numerical will be in terms of, for instance, you will be able to look at that the attitudes of a person, attitudes or opinions of a person. This is purely, if you look at it, it is purely from the point of view of the social sciences. Okay, for instance, when you look at the numerical data, you will be able to look at that numerical data into two. One is discrete, other one is continuous. It is also applicable to the science. The discrete is about fractional in sense and finite in nature. Finite in nature. Continuous is, this discrete is non-fractional and as well as patience guides the process of analysis by doing it's a fractional as well as infinite in nature. Discrete is non-fractional as well as finite. Continuous is fractional as well as infinite in nature. For example, one would like to give you is that look at the temperature. Temperature, height, weight of an object. If you look at, for instance, discrete in terms of number of people in a house, or number of people being affected by a disease, these all are, for instance, discrete, which moves from one value to a second value. Okay, but this is fractional in terms of, for instance, 60.77 as a kind of a temperature. The height as 171 centimeters. Okay, 171.2, 171.3 centimeters. So here the continuous in terms of a fractional, that means the values, which means the values can be arranged within a range, within a given range. Values can be arranged within a given range. Okay, for instance, if you look at that, the temperature, you will be able to keep that 50 to 65. You will be able to keep the 60.7 somewhere between this particular range. So the continuous and the discrete, whether you have to look at that, what is the nature of that particular data in a numerical sense. But if you look at that, coming to a kind of a non-numerical understanding, it's about the attitude, opinions of a person. But if you come to a kind of an science, in terms of an understanding, in terms of a science, you will be able to see this non-numerical in terms of your assumptions, or put it in a more kind of an hypothesis, which are yet to be proved as a kind of an